Okay, so let's dive into implicit differentiation. It says to understand how to find dy dx implicitly, you must realize that differentiation is taking place with respect to x. That means when you differentiate terms of x alone, you can differentiate them as usual. So if I say what's the derivative of x cubed, you would say 3x squared. If I said what's the derivative of x, you would say 1. Okay, this means, it says, but when you differentiate terms involving y, you must apply the chain rule because you are assuming that y is defined implicitly as a differentiable function of x. In other words, what we're saying is the derivative of x cubed is 3x squared because it's a function of x. But the derivative of y cubed would be 3y squared y prime. So we need to add that y prime on. We do not need to add the x prime on because we're taking it with respect to x. So it says, note, it may be help to think of y as a horrible function that you would never want to differentiate, like y equals the fourth root of 3x to the fourth minus e to the x times the natural log of x plus the seventh root of x to the fifth, all over 3 to the square root of x minus 5 over the fourth root of x to the seventh minus 5. Wow, that's ridiculous. I typed up the most ridiculous thing I can see there. Because if I said, what's the derivative of that? Technically, you could find the derivative of that. Now, it might take you multiple days, and you might make up multiple errors in finding the derivative of that, but technically, you should be able to find the derivative of it. It doesn't exist. But if someone says, what's the derivative of that? I want you to simply say y prime. Now, the book, again, uses dy dx. I use y prime, just because of my lazy notation. So it says, if someone asks what's the derivative of y squared then, well, that would be that whole thing squared, right? Well, wouldn't you just use the general power rule? You'd drop the 2 in front, keep the inside just the same to the power minus 1, but then you'd have to multiply times the derivative of the inside. So what did we just say? We're using the general power rule. It would be 2y y prime, or to them 2y dy dx. So let's just get comfortable with how do we differentiate implicitly? So we're not solving an implicit equation yet. We're just saying, can you differentiate individual terms? So what is the derivative of 4x cubed? Well, that's exactly what we think it is. 4 times 3 is 12. Then it would be x squared, right? Because the variables match, and it's very important that you see this, the variables match, we don't need to add x prime. But now notice on the next one, you have x's and y's. The variables don't match. Anytime the variables do not match, you need to add the y prime, or whatever the variable is, prime. So here you would do 3 times 2, which would be 6y to the first, which is what you normally do. But because the variables don't match, you need to add the y prime. Okay? Let's look at the next one, x plus 5y. Well, what's the derivative of x? And again, notice the variables match there, versus the next variables don't match. So what's the derivative of x? That's simply 1, just as we always know it. What's the derivative of 5y? Well, that would be 5 times 1 is what you would usually write. But here we don't say the derivative of y is 1. We say the derivative of y is y prime because the variables don't match. Let's continue on. How about the derivative of xy cubed? Well, that would require a product rule. It would be first times the derivative of the second plus the second times the derivative of the first. So we'd have the first, which is x, times the derivative of the second. So let's think about what's the derivative of y cubed? Well, that would be 3y squared. But then remember, variables don't match, so we need to add the y prime. So that's x times 3y squared y prime. That's first times the derivative of the second. Now we need plus the second, which is y cubed, times the derivative of the first. Well, what's the derivative of x? It's simply just 1. So what's another way we could look at this? We could look at this as 3xy squared y prime plus y cubed. Let's move on to the next one. How about the derivative of the natural log of y? Well, the derivative of the natural log of x is 1 over x, so the derivative of the natural log of y is 1 over y. But then remember, we have to multiply times the derivative of y because the variables don't match. Let's keep on going. How about the derivative of e to the xy? Well, if you remember, for derivatives of exponential functions, all you do is copy and paste. So that would be e to the xy, but then we need to multiply that times the derivative of xy. Well, the derivative of xy requires a product rule, doesn't it? So this would be equal to e to the xy. The derivative of xy would be first, which is x, times the derivative of the second, which would be y prime, plus the second, which would be y, times the derivative of the first. The derivative of x is just 1, so we'll leave that. So what is it equal to? It would be x e to the xy y prime plus y e to the xy. As I distribute it, it would be x e to the xy y prime plus y e to the xy. Let's move on to that last one. The last one says the square root of y plus x squared minus 4. If you remember, this is really just y to the 1/2. So what would this be? The derivative of y to the 1/2 would be 1/2 y to the negative 1/2. But then remember, we need to add that y prime because the variables don't match. Plus, what's the derivative of x squared? Well, that's simply 2x. We don't need an x prime, the variables match. And the derivative of negative 4 is 0. So what would we have on this one? We'd have y prime over 2 square root y plus 2x if we put it back into radical form. Of course, on this problem, we're not at the end of it. I mean, we are at the end of it for this particular problem, but this is just going to be a piece of another problem that we see. Okay, so let's see what it says. Guidelines for implicit differentiation. It says, consider an equation involving x and y in which y is differentiable function of x. You can use the steps below to find dy dx. So the first thing you're going to do is differentiate both sides. Remember, the derivative of y is y prime, okay? And the derivative of y cubed is 3y squared y prime. And if it's xy, you need to use the product rule, okay? So everything that we just did on this page, you're going to differentiate both sides of the equation. Then what you're going to do is you're going to get everything with a y prime on the left-hand side of the equation. Everything else goes on the right-hand side of the equation. It's just like solving for y, except now we're solving for y prime. Then you factor out the y prime from the left side of the equation, divide by whatever's left. Your final answer most likely is going to have x's and y's in it, which is perfectly fine.